like having that tray here. It allows me to put my tools down. So I've already actually tried the radial bearing in this to see if it's gonna fit. And this is worked out to be a 14 millimeter, and that one was a 9/16. So I got that to work, and I'll counterbore this face enough to actually take up the difference so we get enough threads on this lead screw here. So I want to make sure not to drop any of this. So I'm going to keep these clean. Those are the 9/16 radial bearings there. And then this is the, this will come out. So that's the washer for the nut. And that's the nut. These ball locks, there's play in these because these ones don't actually go all the way through and land on the chamfer on the plate. So they're waiting on the ones from Fireball. I hope that solves that problem. If not, I can use shoulder bolts to bolt this down. It's just so quick with the ball locks. And since it's all a relatively precise fit, I don't think there's gonna be that much play. And I don't really plan on beating on these either. Okay, there's the screw. And then there's that 14 millimeter. So since this thread is larger than this shaft, I was able to actually thread these on here and not have to go with a larger screw. So there's very little play with these actual, I said radial bearings, but these are thrust bearings. I made a mistake on that. And you know what, I'll take the actual jaws off as well. So there, and that slides in there. You know, that's pretty smooth. I might add some lapping compound in there just to take down any high spots. But I'm gonna take the, you know what, I don't think I can get the jaws off that easily. So maybe I will, oh, can I hold it in here? Let's take a look. I just try to do it here. Now I'm gonna have to hold that in the vise. Good thing I have another vise here. Okay. All right, so I'm gonna use these. Well, these are just the 3D printed pipe jaws. Let's see how well, oh, I'm gonna do it, I think, like this. No, that ain't really gonna work. Let me do it like that. Need somewhere to hold on to this. So that's why I like these vises. I think they're real versatile for doing this type of work. All right, let's see, we got one out. Get a rag on this screwdriver. Like I said, I'll replace these with that. These are 5/16 18, so I'm gonna use a low profile socketed cap screw. And I'll keep the hard jaws around, but you know, I don't think I'm ever really gonna use these, but it's kind of nice to have. Get a hold on that. And that one's ready to get put in the lathe and counterboard for that thrust bearing. I'm over at the lathe and I wanted to do the bore on the dynamic jaw of the vise. This is a lathe job, right? It's real simple. Just bore this hole out for the depth of that thrust washer and thrust bearing assembly. Problem is, this is 2 3/8 here. I'm just use a tape measure. Oh, I guess it's about 2 1/4. The bore on the through hole on the lathe is 2 1/8. I've encountered that issue before where the ram on the arbor press is 2 3/16, so I had to run a steady rest. Yes, it worked, it just takes a little bit more time to set it up. So I tried it in the 8" 3 jaw, wasn't gonna hold. Won't go through. The bore on that I think is the 2 1/8. This is 2 1/4. Luckily my 10" 3 jaw, it holds, it goes through. And then I checked the dimension on the actual lathe here, and the dynamic jaw goes in about 6 inches. So, and then this chuck here has a 4" hold, or maybe it's another 6. So I got 12 inches So it should be perfect. I should have plenty of hold on that, and let's just hope it clears the ways on the lathe. And yes, I could remove the gap, but again, that's a more work than I want to do. So I also thought I could set it up in the mill and use I have these 2-axis CNC prototracks, really convenient for doing basic work.
So I lost some audio on the next couple of clips, but it's easy enough to do a voiceover. So I'll show you guys that stack height I have on this old Enco mill with the ProtoTrack 2-axis conversion. So I can get actually 18 inches between the table and the spindle. And that dynamic jaw is 15. So that'd give me enough room to actually get an end mill in there and interpolate it. And this machine is so easy to run, I can actually just program it, and it will do that. So now I'm here on the lathe. I'm going to install this 8-inch, sorry, this is the 10-inch 3-jaw. So this just has that little larger clearance, and I can actually get the dynamic jaw of that 2 1/4 diameter through here because it has a large enough opening. And then the spindle on my lathe is an MT5, so it'll that end will clear and it'll fit in there. So I'll have plenty of hold on it, and it'll work out just fine. Here I'm removing this stainless chip pan I made. So this works really well for if it doesn't get in the way, but since I'm running the larger chuck and I have that parts, the dynamic jaw spinning around, I almost guarantee it's going to hit. So it's easy enough to pull this M6 or it's M8 bolt out of the back and just remove this stainless tray. I like running this because it really keeps the machine clean. It has that lip in the front. Okay, here we go. Getting the dynamic jaw installed in the machine. Fits in the 3-jaw, no problem. And clears the ways, and no real issue here. So I'm indicating the actual barrel of the vise, and it's within a couple thousandths, no issue. The same cannot be said for the actual hole in the front here. This was out like 50 thousandths. Turns out it didn't really matter. This was just a clearance hole because the actual screw is undersized. Then I go in and I decided, well, I'll just leave a little bit of extra play for that thrust bearing. So the diameter of the bearing is 1.7 or 1.173. So I ran it, I said, let's just make it at 1 3/16. And I left, it's a 5/32 deep. And I left about, I think, 10,000 stick out of the assembly. And I tried it, and it worked. So I ran the second one. And I was very happy with that.
Okay, so I am done with the first modification on these Doyle pivot vices. That's adding that counterbore to the actual dynamic jaw so I can run a radial bearing. So I'll bring you guys in a little closer and we'll do the assembly of that so you see how it goes. All right, so we're going to just do the assembly on this one here. Since I had all these apart, I decided to add a lapping compound, like a 400 grit, to pretty much all the moving surfaces like the dynamic jaw and the pivot once it's all assembled. And I did the base too. And I got to tell you, that really smoothed things out in there. So I just took down the high spots and then I cleaned everything real well and re-greased it. And I'm very impressed with that. I think that turned out great. So I labeled these. I figured, well, they're all come out of the same factory, but since I did lap them, let's put them all back together the same way. Unfortunately, this one the dynamic jaws got mixed up, but they all got lapped in the same unit, and I center punched them 1 dot for everything in here and 2 dots for this one. So when I take them apart again to do my next modification, I know how they go back together. And then we added this is a 1-inch diameter ball I had, so there was like a little kind of large, it looked like head of a screw on the back here, and I think this is just a little easier to grab. And this one actually has a 7/8 ball, which, either way, can't tell that much of a difference, but just try them out. So let's put the screw together. These are both the same. I had mentioned before that this radial, I keep calling it a radial bearing. Thrust bearing is a 14 millimeter because this thread is 3/4, but this shank is like 11/16. So I got lucky and this kind of just fit in there pretty well. So you kind of have to thread these on there. I had to file the end of that thread down a little bit, but it will go, or it did go. So just kind of need to, let's see, and I there we go, just barely tap it, and then we get our bearing
And I'll grease these after they go in. Kind of hosed everything down with WD-40. Just thought I would clean off whatever grease they put on here. And I don't know if I'm going to... Okay, there we go. We got our last one there. Okay. So we're definitely going to want to grease this. Let's see where that one go. Let me just put it just did me. I don't want to dent it at all. All right, so I got that greased up. I decided to put a little grease on the threads. So this guy will fish in there. And I've already actually put the ball detent in this, which you're going to see in the next video. But since I had it apart, and I'll put the old handle in to spin that down. Just so we'll spin this down. You can see how kind of awkward it is not being able to center that. Okay, so there's that setup. Now we're going to pivot this back, and I'll bring you in a little closer to see the bearing that gets installed in the back. Okay, so now we're ready to install the thrust washer and bearing on the back side. So it's kind of confusing because this. The front takes a 14 millimeter, and the back is this 9/16. So this has already been greased, and that's a better fit there. And we have our nut. See here. We don't want to tighten this up too much. Just that actually feels pretty good right there. And eventually when I'm done with this, I will add Loctite to that nut too, because we're only grabbing on just right on that end of the nylon. Okay, that concludes the first modification to these Doyle bench vises, adding the thrust bearing and washer to the front dynamic jaw, and then just behind the nut in the back of the screw. So that seemed to really help these out. It just makes them a lot smoother. I can already feel that. And then also off camera, I mentioned I had lapped all these surfaces, and they just function really nicely now. So since they're apart, might as well do it. And it's just a little extra touch. So next video, I'm going to add the ball detented handles to these and show you making those and putting them together. So thanks for watching, and stay tuned for part 3.